Hello, today I'm going to talk about the Google Summer of Code 2023 for KDE, what I would do if I were a student. So the very first thing to do is go to Google and search for KDE GSoC 2023. It gives as results the two web pages that we need. The first one is the general one about Google Summer of Code, and the other one is the part with ideas for Google Summer of Code 2023. So first of all, you will be reading this, and then you will be reading this. Let's say as an example that we are looking at the GSoC 2023 ideas for calendar. So there's one: calendar invitation, improved multi-platform support, mail integration, implement calendar availability, accessibility improvements. Okay. Mentors Carl Schwan, Claudio Cambra. Okay. It says in here that a good communication channel would be the calendar channel on kdE.org metrics. Okay. Let's read something about what we're supposed to do during this GSoC. So this is mostly ideas for this year. Okay. And at the start of the page, it says that these ideas were contributed by the developers themselves, that there is a general KDE development mailing list. So let's also copy this thing. Okay, we should look at the KDE mailing lists page for information. So the KDE mailing lists are one of the main communication channels in the KDE community. Let's look at how the KDE devel mailing list looks like. So there's an archive of KDE devel. So these are all of the mails that were sent in March 2023 to the KDE-devel mailing list. They are just regular emails. Okay. And there's a subscribe web user interface, where after you create user email account specifically for free and open source development, so you should have an email address that's specific for you doing free and open source contributions. I suggest you create that email address on Gmail, and then you fill that up in here. So you put your email in here, and optionally a username, password, and if you want to receive a batch daily. I'm not a robot, subscribe. Then you will start receiving the same emails that you can see in here in the interface with the KDE-devel archives. So these emails. Okay. If you have a question to ask, then to post a message to all the list members, send an email to here. So using your email account that's on Gmail, that's for you contributing to free and open source software, you send an email to KDE-devel at kdE.org. Okay. Then on the other page, which is the page for Google Summer of Code, let's see what it says in here. So there's information about Google Summer of Code on the Google Summer of Code website. You will need a Google account, hopefully, because you will need a Google account in order to contribute to the free and open source software. All KDE students need to join the KDE student list. What is this? So it's another mailing list. You put your email address in here, password, and you will receive these emails. Okay. Next. If you do not have a KDE account set up now, which means identity.kde.org, okay. So programming language you will need to have programmed before. If you did not program before, then you're not going to be able to qualify. And the programming language for the KDE Git repositories is C++, and some KDE Git repositories, such as the one that we're suggesting right now, which is Calendar, also does contain another programming language which is called QML. Okay, so C++, the programming language. Some people study it in high school or in university. Some people started with Turbo C++ in DOS. Okay, include IOStream, stdkout. The other programming language is QML. Which is a programming language from the Qt framework. File extension is QML. Looks like a declarative tree. So it goes top level, just one GUI control, which is called rectangle, which has a child GUI control, which is of type image. The rectangle is called canvas, and the image is called logo. And then there's properties of each GUI control being set in a syntax similar to JSON. Okay. Next. Instructions for potential contributors. An important professional opportunity. The KDE developers that will mentor you will dedicate a portion of their time to mentoring you. Commitment is the most important thing. You need to be committed. As a student, you need to be committed. Experience in coding is really important. If you do have some experience with KDE or Qt, that's even better. And then you're taken to the separate wiki page for getting started with KDE development. So if you want to start programming for KDE, this is the page to go to. Okay, so this wiki page serves two purposes. this is the procedure how to start programming for KDE, and this is the procedure for setting up kdesrc-build, which is the framework that we use in order to build KDE Git repository. So KDE has more than 400 Git repositories, and kdesrc-build is the framework that builds the repositories in the correct order, with the correct build flags, in the correct directories, with the correct environment variables, everything correct Git branches. Okay, let's start with prerequisites. So KDE software uses C++. It also uses QML. Do look at some YouTube videos. There's good long YouTube videos for how to program using the Qt toolkit, for how to use the C++ programming language. Okay, and then while programming for KDE, we always use Linux, the Linux operating system, and we use the Linux operating system either installed on hardware, computer or laptop, or in a virtual machine. We do not use macOS, we do not use Windows, we do not use Docker Linux containers. So we use Linux operating system installed on hardware, laptop or computer, or in a virtual machine. Why? Because we want to edit the master branches of KDE Git repositories, and those are being developed, and we know they work correctly and built correctly using Linux. Okay. If you're on Windows, and many of the students are on Windows, then you would create a Linux virtual machine. This is the example that you have. The example is using VirtualBox. So on Windows, you just download VirtualBox. Many of the students do not have Windows Pro. They have Windows Home, which is a not that great operating system. So it's better to have Windows 10 or 11 Pro than Windows 10 or 11 Home. Okay. This tutorial suggests that you use a Linux distribution called KDE Neon. From here. Okay. The guest OS is the operating system that runs inside of the VirtualBox VM, which is KDE Neon. The host OS in some cases might be Windows, so the operating system that runs on the hardware computer. Okay, so in here it shows how you would create such a virtual machine. So I would recommend against VirtualBox because it's the slowest solution out there. If I am on Windows, I use Hyper-V. But then VirtualBox might be your only solution if you're using Windows 10 Home, not Pro. Okay. Then I would never go for just 2 megabytes. That's way too low. Way too little RAM, because inside of the virtual machine I'm going to run the latest version of the integrated development environment Qt Creator. So I'm going to assign to this virtual machine at least 10 gigabytes because I have 32 gigabytes of RAM on my hardware machine. Hard disk, I will go with at least 250 gigabytes, even maybe more, because I have 2 terabytes of NVMe PCIe 3 on my hardware machine. 20 gigabytes is totally not going to be enough. Okay. And then in here it says install guest edition CD image. I would also do this differently, but that's an advanced topic. I would install the XRDP and org XRDP package inside of deb package inside of KDE Neon, and then I would connect using an RDP client called X3RDP to this virtual machine. Okay. If the hardware machine is running Linux and it's not the best Linux distribution, that what I would do, I would create a virtual machine using the virtualization software Virt Manager. So this thing, Virtual Machine Manager or Virt-Manager. This is the best and the fastest virtualization software that I know of. And it's free and it's built into most Linux distributions. So do use this if the hardware machine runs the Linux operating system. Okay. And then which Linux operating system are we going to put inside of the virtual machine, or if we're going to have a hardware machine, a laptop for instance, and we want to install a Linux distribution on that laptop, which Linux distribution should we choose? Where there are some Linux distributions that are better suited for the framework kdesrc-build, and these are the rolling release Linux distributions, which means Arch Linux or its derivatives such as EndeavourOS, OpenSUSE Tumbleweed, KDE Neon, the distribution that we just saw when we created the VirtualBox virtual machine, or the latest version of Fedora KDE Spin or Kubuntu. So not Ubuntu but Kubuntu, and not Ubuntu 20.04 but Kubuntu 22.10. So the latest, greatest version of Kubuntu, nothing else. Okay, so the latest version of Kubuntu is 22.10, not this thing, 22.04.2. So this is not the latest version, it's from April 2022, whereas this one is from October 2022. So use the newest one. Okay. We're not going to use Windows or macOS or FreeBSD in order to develop for KDE. If we have these operating systems installed on the hardware machine, then we're going to run a virtual machine. Pay big attention if your hardware machine is Apple Silicon, then you will not be able to run the virtual machines that we recommend, because these are using Linux Intel AMD 64-bit CPUs. Okay. Then we're at the step setting up the development environment. So setting up the development environment means setting up the framework kdesrc-build. We're going to use Qt 5 and KDE Frameworks 5 because this is the default. We're not using Qt 6 and KDE Frameworks 6 because that is an advanced topic. The source code for KDE software lives in a forge of type GitLab installed at https://invent.kde.org. To accomplish these tasks, you will need to enter commands using your terminal. So right now you should have your Linux operating system ready, either in a virtual machine or installed on the hardware computer or laptop, and the Linux operating system should be one that's better supported by kdesrc, which is my case because I'm on Kubuntu 22.10. So says open a terminal program such as KDE's console. Let's do that. So this is the KDE Plasma desktop start menu. Okay, click on this icon and it says console or terminal. Let's click there. Okay, let's put the documentation on the right hand side of the screen. So I click on the title bar of a window and then I drag it such that it bumps the right hand side margin of the screen, and now it's stuck and is going to use the right half of the screen. Okay, the right half of the screen I often call documentation, and the left hand side of the screen I often call work. So let's go there. It says start console. I did that. Many students do not know Linux operating system, do not know Unix, do not know the Unix command line, what bash born again shell is, that there's a process tree in Linux, how to kill processes, how to start processes, what's the command line, what does ps aux do, what does ps3 do, okay, what systemd is. Students that want to program for the GSoC oftentimes are Windows only, are in university, and have very few knowledges about programming languages, about Linux, about Unix, about the distribution that they're using, such as Ubuntu 22.10 in my case, so they don't really know how to install packages from the command line, etc., etc. So all of these skills you should start learning now. So that's why the wiki page says if you're not the best at knowing how to use the Linux command line, then now might be a good time to start learning about the command line. So do this tutorial, so follow it along. If it says ls minus lsr, then you just copy that thing and paste it in your terminal and see what it does. Okay, so do follow along. Find out how the file system looks like, how you can change from a directory to another, how you can do copy files, touch files, move files, relative paths, absolute paths, what tilde is, what cd minus does, takes you back to the previously directory that you were in, what pwd is, what whoami is, what which does. Okay, so do follow this tutorial. And I also have my tutorial for Unix in general, the terminal. So this thing, Unix command line tutorial, do that. Follow it along and do whatever I do in this YouTube video. Okay, next. There are video versions. First of all, do look at this YouTube tutorial. Okay, there are more versions, video versions. Pick the distribution the Linux operating system that you have installed, and each of these Linux operating systems has at least one YouTube video in here. Do watch the corresponding YouTube video. So if you're on KDE Neon, do watch the KDE Neon YouTube video. It's important. Okay, let's hope that you followed the Unix command line YouTube tutorial, that you followed the video version of setting up kdesrc for your Linux distribution. And now we're going to follow the steps. So it goes set up kdesrc-build, step 1 out of 6. We're going to run this thing. So right click in the web browser, Firefox in my case, copy, and then right click in console to paste. Okay, it says you wanted to become a super user, which is the root user. The root user has complete rights on this Linux installation, can do absolutely everything. And then you said apt, which apt is the package manager from Kubuntu 22.10. To it we told install, which is the verb, so package manager install, and then a list of packages to install. So these are in fact deb packages and live in the repositories of my Linux OS, so Kubuntu 22.10. 3 packages, git cmake dialog, and says git was already installed, cmake was already installed, dialog was already installed, so nothing to install here. Okay, great. We're going to skip the configure git step, and then we're going to get back to this step. Okay, set up kdesrc-build, step 2 out of 6. Okay, let's copy this thing in a text editor and see what it does. So it says if you have an old installation of kdesrc-build and you want a clean installation, run a command like this. So let's actually run a command like this. Okay, it doesn't do anything because the source file does not exist and the source directory does not exist. You should know by now what mv does because you followed the tutorial. Okay, and then we can run these 3 command lines at once. So you go paste and go. So what it does, it creates the directory tilde, which is the home directory. So the home directory is /home/my username, which is tilde, and then kdesrc-build. Okay, so this absolute path is identical to this relative path. So tilde/kd/src/kdesrc-build is identical to /home/my username/kd/src/kdesrc-build. Okay. Then it says that I should run this command line. So let's run it. Okay, this also tries to install a ton of binary packages from my Linux distribution, from my Kubuntu 22.10. All of them are already installed, so nothing to install here. And then it says it has created this configuration file, so we'll need this path later. Copy it in here. And then it asks, do you use bash? And yes, I do. Do you want to update the bash configuration file? And I say yes. So you choose yes, and then you press enter. Like this. And then it says that to my tilde/bashrc, it did some modifications. So let's actually look at both of the things, the modification to this file and the fact that this file has been created from scratch. For that, we need a text editor. The text editor that I recommend is Kate. Let's go at the end of the file. So for that, I go right click in the minimap and scroll here. Okay, so there's this comment, and we can see that this comment is paired with this comment. So line 126 is the start of the block, and it ends on line 162. So this is the block that was just added by kdesrc-build space -- initial - setup. What it did is two things. It created a auto-completion function named kdesrc-run, so for kdesrc-run auto-completion, and then it prepended to my path environment variable the directory tilde/kd/src/kdesrc-build, so the directory where I git clone the git repository, the KDE git repository kdesrc-build. That git repository contains executables written in the Perl programming language, so there's nothing to compile there. Everything's executable and can be run directly because they are Perl files, and Perl files are interpreted, and all of the Linux operating systems do have Perl pre-installed. Okay. Then let's look at the configuration file listing. So for that I go Kate, and I can select, and I click on the mouse's scroll wheel, which is the middle button. So I paste using the middle button on my mouse, which is clicking once on the scroll wheel. Okay, so this is the default configuration file that's created by kdesrc-build initial setup. It's called kdesrc-build rc and lives in the directory tilde/.config. So default values, we should keep them as they are. But in here, I always go debug because I'm a programmer and I'm using an IDE which is called Qt Creator, and I debug a lot. I run using the debugger, often the KDE Git repositories. Okay. Then I have 16 CPU threads, so I'm going to make use of all of them, like this. I'm not going to just use 4 CPU threads, I'm going to use all of them, which is 16. The rest I just keep defaults. So the only things that I changed is line 37 num cores, I put the correct CPU thread count, and then line 26 I replaced rel with debinfo with debug, Ctrl S. Okay, then it says I should source the bashrc file, copy, and right click, paste. Okay, and to make sure that I have really sourced the bashrc file, I'm going to echo $path, which in Unix and Linux and Windows and everywhere else, each program that runs has a thing which is called the environment block, which contains the environment variables, which are these. Less is a paginator. Okay, so these are the environment variable. There's an environment variable called bash that has the value /bin/bash. There's an environment variable called desktop session, and its value is plasma. There's one called KD session UID, and the value is 1001. There's a really important one which is called lang for language, and the value is English US UTF-8. Old PWD is the directory, the previous current directory, so the directory that I changed into the current directory, which is probably going to be used by cd --, which takes you to the previous current directory. Path, this is an important environment variable, says if I run a command in the command lines, for instance, if I run the command true, this one. It's going to search for a file that's executable, not in the current directory. In Linux and Unix, the current directory is not part of the environment variable path, so it's not used when looking up where there's a binary, an executable named true, but instead it looks inside of the environment variable path. So this is how it looks like. It starts from here and ends here. It splits the string, that's the value of the path environment variable, by the semicolon. So there's 1 semicolon, 2 semicolons, 3 semicolons, 4 semicolons, 5 semicolons, etc. Between these semicolons there's names of directories. So it computes an array of directory names, full paths of directories, and in each directory it searches for a file that's named true and that is executable. Let's find out in which of the directories there exists a file that's true and it's executable. Which -a true. And there's 2 such directories. There's /usr/bin/true and /bin/true. Okay. Why does it offer /usr/bin first? Because /usr/bin in the array of directories is before /bin. So this thing is before this thing. So that's why it's going to prefer to take the true executable from /usr/bin, not from /bin. Okay. If I go just which and true without the -a parameter, it's going to tell me if I were to run the true executable, I would find it in /usr/bin and run it from there, which is exactly what it does. Okay. So let's actually run echo $path to see that the environment variable path starts with the directory where we git cloned kdesrc-build. So that's ~kd/src/kdesrc-build, and that's it. The very first directory in the environment variable path is exactly that, the directory where we git cloned the KDE repository kdesrc-build. Okay, how does that look like? So this is my home directory, which is tilde. I go to the directory KDE, and in there's just one subdirectory, which is called src. In there's just one subdirectory, which is called kdesrc-build. And in there's an executable called kdesrc-build. We can see it's executable by right-clicking on it, properties, permissions, and it says is executable. This checkbox is checked. Or from the command line, we could go ls -l and kdesrc-build. There's auto-completion at the command line. If I press tab, it auto-completes correctly. So the tab character on my keyboard auto-completes file paths and directory paths. Okay, and this is the chmod, and the chmod says that I have executable rights on this file. So this file is executable to me, to nmariusp, my Linux user. It's executable by the members of my Linux user group, which is called nmariusp also, and it's executable by anybody else, by all Linux users. Okay, and kdesrc-build again is a Python script and looks like this. Says shebang /usr bin env perl, and then it does perl things. So it has comments, it has use Python version, Perl version, use strict, use warnings to variables, etc. Okay, so we did source bashrc, and then we did echo $path. Okay, so it says that a file tilde/.config/kdesrc-build was created. Make sure that after the line global it contains branch group kf5qt5. We just looked at this configuration file and indeed after global it has this line. Let's look at the help. Okay, I'm going to put it in here, Ctrl+S. So you really need to know the output of kdesrc-build --help. No src does not do git operations. src only does only git operations. Refresh build rebuilds this module and all of its dependencies. Stop on failure stops at the first module that cannot build. Include dependencies is default. You might probably want to use no include dependencies to build just this module, not its dependencies. Okay, we're not setting up any Qt, we're just using Qt from the Linux OS. Disable indexing for your development environment. Let's look at that. So system settings, index, file search, and in my case is totally disabled. So if you disable it, that's an advanced scenario. We recommend this scenario that's shown in the screenshot, where we enable file search, but we tell it to exclude tilde/kd to not be indexed. Okay, then set up kdesrc-build step 3 out of 6. Says that we need to install at least the dependencies needed to build all of the KDE frameworks, and we need to go to this page. Okay. So let's look, enable the source repositories. I'm on Kubuntu, so I need to run this thing. So as a super user, sudo, which runs things as the Linux user that's named root. Okay, let's see exactly what this command line should have done. I become a super user. I install a command line text editor. So apt install. This is the one that I can survive in. Emacs no X. It's already installed. And then I go Emacs, and let's look at the content of this file. Middle click paste. Okay, so each line that starts with deb space should be followed by an identical line that starts with deb minus src. So deb space something, deb minus src space is that exact same thing as above. Okay, so deb src line identical to the one above, deb src line identical to the one above, deb src line identical to the one above. Two more. 1, 2, 3, 4 more. And that's it. Ctrl+X, C to exit. So this command line has been successful. It has added after each deb space line a similar line called deb-src. And then this apt update, apt is the Linux package manager from Kubuntu. It says download from the Kubuntu server the metadata about available packages. So on the Ubuntu server, there's two things. There's the packages themselves, which are files with extension deb, and then there's metadata about the packages. So it's information such as in this Kubuntu package repository, there are 20,000 deb packages. If you want to install the package A, you will also need to install the package A1, A2, A3, A4, A blah blah. So it knows the dependencies between deb packages. Okay, so this was step 4 out of 6. Okay, if you cannot build Dolphin, then what you want to do is sudo space apt space build minus deb Dolphin. If you cannot build kcalc, then sudo apt build deb kcalc. So the package that you cannot build using kdesrc-build, you will run a command line like this if you're on Kubuntu. Similar instructions for other operating systems. Okay. Then we want to install deb packages for all of the KDE frameworks version 5. So that's setup kdesrc-build step 5 out of 6. I'm on Kubuntu, the same instructions for KDE Neon. I want to run this command line. Copy and paste. Okay. Says that all of the packages are up to date. Next, other Linux operating systems. And if I'm going to build Plasma, which is the desktop environment, so this thing that you see in here, this panel, this start menu, this window manager, etc., then the line to run is this thing. Okay. So with that, we did steps 4 and 5 out of 6. Let's get back to where we started. So we were at step 3. We did step 4 and 5 inside of this URL. The next thing that we want is step 6 out of 6, which is building KDE Frameworks version 5. If you do not have enough space on your virtual machine or on your hard drive or on your SSD, then you might survive if you skip step 6 out of 6. I always run it. Control D to not be a super user anymore and return back to my user. And then I run this command line. Okay. So let's look at KDE invent for frameworks. So right now, the kdesrc-build framework has been asked to build all of the KDE frameworks version 5. In order to find out which are these frameworks, it git clones the KDE Git repository sysadmin repo metadata, and in there it says that frameworks are 88 KDE Git repositories, and they are from here. So Baloo, Barcode, Bluesy, Breeze Icons, ECM, Karchive, KUTH, Kbookmarks, Kalendar, Core, KCM, Utils, Kcodex, Kcompletion, etc. It will build all of these in the correct order, because I know kconfig depends on k internationalization or something. This is the k internationalization KI18N. Okay. While this thing is building, I recommend that you go to my channel and watch my screen recordings about starting programming for KDE. So it's this one. This thing. And I have another one, which is my listing my algorithm for starting programming for KDE. So this will tell you about the online accounts that you need to create, that you should set up kdesrc-build, etc. All that you need in order to start programming for KDE. Okay. So by now you have already watched my screen recordings for how to start programming for KDE, how to start learning about the Unix command line, this one, and the screen recording about your Linux distribution that you have chosen. So if you have chosen, I know, Neon, KDE Neon, you should have already seen this screen recording, create KDE Neon VM and set up kdesrc-build tutorial. If you're using VirtualBox, then you probably have already watched this tutorial. Otherwise do watch it. So VirtualBox, KDE Neon Developer Edition and kdesrc-build tutorial. Okay. Let's stop the build because it's going to take a while. So it's only at module 18 out of 88. Control C. I already have more than one kdesrc-build installations running on this machine. So that's why I'm going to actually delete the kdesrc-build installation that I just did. And I'm going to use one of the other kdesrc-build installations that I have on this machine. Okay. So that means this thing. Don't do this at home. So ignore what I'm doing right now. Okay. So back to where we were. We need a kdesrc-build installation. So I have such a thing in the directory kd.5. So it's the exact same thing as you have in ~kd, but on my machine it's named ~kd.5. Okay. The next thing to do is to build the project that you want to do your so that was step 6 out of 6, kdesrc-build frameworks, and that's it. Everything else is extra, so you should have built an application such as KCalc. But the application that we're going to work on as part of GSoC is actually called kalendar. Okay, so it says in here, kalendar. Let's see where this lives in KDE invent. So it's https://invent.kd.org/pim/calendar. PIM means personal information management. So that means emails, calendar, appointments, to-do lists. Let's exactly look at this group. So this is called a GitLab group, PIM. So applications, libraries, add-ons for personal information management. Akonadi is the engine that reads mail. Aggregator is a RSS feed reader. Itinerary is if you are going to use a plane and do you want to board a plane, then that's the application for you. Address book, calendar, the application that we're going to work on. What else? KJOTS, note-taking application. Cleopatra, OpenPGP, certificate management. Kmail, this is the email client application. Knotes, note-taking application. Contact is a wrapper, contains an application that has embedded inside an email client and other PIM applications. Key organizer is the calendar. So there's two calendars. One is called key organizer, the other is called calendar with a K. Okay. Trohita is a IMAP email client. Vaccination is for vaccines. Zanshin is a getting things done application. Okay, so you need to remember that the engine is Akonadi and that calendar is for events, it's a calendaring application, and it's written using QML and Qt and C++, whereas its sibling is called KOrganizer, and this application does not use QML. So there's two twin applications, KOrganizer and calendar. The difference is that calendar also uses the QML programming language. Okay, so let's go. In order to build anything, any KDE Git repository, we are going to use the kdesrc-build framework, and we're going to tell it the name either of a group of KDE Git repositories or the name of a Git repository, the Git repository to build. Okay, and what we want it to build is to build calendar, this application, the one that we're going to work on. Calendar, like this. Okay, so it sees that kdesrc-build looks at the KDE Git repository sysadmin repo metadata, decides that there exists such a KDE Git repository named calendar, and that it depends on 94 other KDE Git repositories. Many are from the KDE Invent group frameworks, and others are from the KDE Invent GitLab group PIM. So it's going to build these 94 KDE Git repositories in the correct order. So the very first one is ECM extra CMake modules, then kcore add-ons from frameworks, then kinternationalization from frameworks, then kconfig from frameworks, then kcodecs from frameworks, plasma variant protocols from another place, then karchive from frameworks, kdoc tools from frameworks, kwidget add-ons from frameworks, polkit qt1 from another place, then kauth from frameworks, kgui add-on from frameworks, kconfig widgets from frameworks, kdbus add-ons from frameworks, etc. Still frameworks from another place, frameworks. So we passed the 30th KDE Git repository and we're still at the GitLab group frameworks. Okay, at the 37th Git repository, we're still at frameworks, but then we got at PIM, the first module from PIM, which is kmime. Then back at frameworks, then Akonadi, which is the engine, which is from PIM. It built all of the modules from KDE frameworks really fast because they were already built. I built them previously. But the PIM modules, it seems that they have changed in the last days. So it will need to build the Akonadi PIM engine again. Okay, so it's almost half done. Let's look at my configuration file. So it's defaults. I changed in here to .5, debug as I did previously, and 16. The rest are defaults. Okay. So by now you have learned Linux, you have learned the command line, you have learned how to set up kdesrc-build. If something goes wrong, you can always, if this is a virtual machine, you can always delete your virtual machine, create a virtual machine from scratch. So install KDE Neon or what Linux distribution you have in there again, and then restart the set up kdesrc-build procedure, follow the videos, if the videos do not work, do tell me and I'll refresh them. Okay, so it finished building Akonadi. We're at halfway through. So we've built module 48 out of 95. I have set up kdesrc-build numerous times on this Linux OS. That's why it builds so fast and it builds without any build errors. You will often have build errors, and kdesrc-build tries to be as helpful as possible and tell you ways that you can fix your error. 99% of times that means installing binary packages from your Linux operating system. So in my case, Kubuntu 22.10, I need to go apt space install something, or apt space build -dep something, or apt file find something. Those types of kdesrc-build errors are called cmake configure package not found errors. Okay, we have so let's look at how you use kdesrc-build. So you just go kdesrc-build and then the name of the a Git repository that you want to build, or the name of a group of Git repositories that you want to build. Okay. Once you have built an application, then you can run it. You go either kdesrc-run and then the name of the application, or in each of the directories inside of the ~kd/build, there's a prefix.sh files, there's many prefix.sh files. in each of the subdirectories of the build directory, and all of the prefix files are identical. So you should go source, one of the prefix.sh files, and then the name of the executable. So if we build kdesrc-build kcalc, so kcalc is this application, the desktop computer from the KDE Plasma desktop. Then you can run it either using kdesrc-run or in two steps. First, you inside of bash, you go source ~kd/build/kcalc/prefix.sh, and then you run the executable kcalc. Okay. Building Plasma is an advanced topic, you should not do it. Building Plasma desktop is an advanced topic, you should not do it. Building Plasma mobile is an advanced topic, you should not do it. Okay, you need to read this chapter and how to solve build problems chapter. And then we have advanced this advanced page, so more advanced topics. And the last chapter is kdesrc-build issues. If you have an issue that you cannot fix using just the suggestions of kdesrc-build, or using the suggestions of other people, or using the suggestions found in here in the chapters iterating on a single object and the chapter how to solve build problems, then we should add the fix to that kdesrc-build issue to this chapter in the page/more. Okay, so while everything is building, now is a good time to tell you how kdesrc-build works. So we have a directory which is called tilde/kd, and in there we have three directories. src, inside of src there are git repositories that have been cloned. So git GUI. So this is how a git repository that was cloned looks like. Everything should be clean, empty, no unstaged changes. If you go repository, visualize all branch history, we can see the history of this KDE git repository. There's a thing which is called a remote origin. There's a master branch that points to this git commit. The git commit can be referenced either by looking at the first characters in the SHA-1 ID, so you could call this git commit 9C54A47, or you can go the git commit from 2023-0306-0933. Okay, both the local master branch and the master branch from the remote origin point to the same git commit, which means that my local git repository is identical to the remote git repository. The remote git repository lives in invent.kd.org, so in here. So it's the akonadi git repository, which is this guy, invent.kd.org/pim/akonadi. Okay, what can we do? We can look at the remotes. So git remote space -v shows all of the remotes. So this is a KDE git repository that's cloned locally, and it's attached to one remote that's called origin using these URLs. I do not have the permissions to write to git repositories in invent.kd.org/something else than my username, but I can write to the git repositories in invent.kd.org/nmariusp, which is my user. Okay. how do you get this application git k? How do you get this application git GUI? Ctrl-Shift-T opens a new tab in console, become a super user, sudo su, asks for the password, and then in my case, Kubuntu 22.10, I go up, install git k and git GUI. The same command line works in all of the Linux distributions that are based on Debian. So Debian, Ubuntu, Kubuntu, KDE, Neon, and many others. Okay, these are the applications that I use. I use Git, Git GUI, and Git K. Some things I do at the command line, such as listing the remotes, but most of the things I do using graphical user interface applications when I do Git operations, and for that I open Git GUI and an ampersand at the end. So this and character. Whenever you start GUI application, it's a good idea to always append the ampersand at the end of the command line. This way the command line gets immediately free for you to do other things with it. So you can type bash commands, in my case, GNU bash bourne again shell. If I don't put the ampersand at the end, the GUI application is going to eat the command prompt, so I cannot run any other commands in bash, because bash is not reading from standard input. Okay. The solution in this case, if you started the GUI application without the ampersand at the end, is actually to close the GUI application. So you can go Ctrl-C, or you can just close it using the mouse, and then you open it correctly. If you do not want to close the GUI application, then you can background it. So that's Ctrl-Z, which says stopped, and then you go BG to background the application. And now it actually has added an ampersand at the end of the command line. So Ctrl-Z to stop, and then BG to background it. Okay. So inside of this directory, kdesrc-build just did git clone, nothing else. Will not write into this directory at all. So kdesrc-build, when it builds things, it does not write to the ~kd/kd/src directory. Instead, it writes to another directory which is called ~kd/build/akonadi. So there's two parallel directories, two twin directories. One is ~kd/kd/src/akonadi with the git clone, and another directory which is ~kd/kd/build/akonadi with the build artifacts. In here, executable files will be built, preprocessors will be run, .so shared libraries will be built, etc. Code generators from Qt will be run. So all of the intermediate files get built in here. Okay, inside of somewhere, I don't know where, bin, inside of the bin directory, there will be the executables and the .so files, which are the shared libraries. Okay, and then the final step in kdesrc-build is the installing step, which actually runs make install in here in this directory. So it does like this: make install. Okay, so we're inside of the ~kd/build/akonadi. We have built everything, and now we can run make install. Okay, it has actually rebuilt everything. I'm not sure why. Okay, and what make install actually does, so in this case it has detected that make install is a GNU make a target that depends on the target without a name. So it saw that it needed to build this module from scratch, so it did that, which is a build dependency, and then it has run the target install, which takes the files from this directory, from /kd/build/akonadi, and copies them to the /usr directory. So /kd/usr directory. The binaries into the bin directory, the libraries, the SO files inside of the lib directory, some files inside of the share directory. So all of the files that you usually can see inside of /usr. So all of these files, the same file structure that you can see in /usr, you will be able to see in /kd/usr. But the /usr3, the /usr directory, is the directory of your Linux OS. So do not write into /usr. It will also, if you want to write into /usr, it will also require that you run the make install step as the super user. So do not do that. Let kdesrc-build do its thing and make install things into /kd/usr. Okay, so you can see the /usr has a bin directory with executables, 1 million executables. Okay. So this is the bin directory. Then I do not know what the min_gw thing is. The libraries live in /usr/lib if you install them from your Linux distribution. So files with the extension .so. Okay. Whereas so we use the Linux OS to install Qt and other libraries that sit below Qt and the KDE applications and libraries. But we use kdesrc-build to build all of the KDE Git repositories. So all of the KDE Git repositories that are dependence of kalendar and kalendar itself, we're going to build using kdesrc-build. So the rule is, if the source code of that Git repository is in invent.kd.org, then we're going to use kdesrc-build to build that. For things that sit below Qt, including Qt, and libraries that sit below KDE, such as the file compression libraries, the image codec libraries, the audio video codec libraries, the X libraries, the Wayland libraries, etc. We install those from the Linux distribution. In my case, in Kubuntu, the command line is apt to install packages from my Linux distribution. Okay. So in here we have just git clones. In here we have the intermediate directories where files are being built. And this is the final directory, /kd/usr, which is very similar to /usr, but this is for files and executables that were, and libraries that were built by kdesrc-build. So kdesrc-build, all of its work, all of the results of kdesrc-build will land into ~kd/usr. Okay. So said that kdesrc-build calendar is successful. It could build all of the Git repositories, 95 out of 95. The last repository to be built is always the one that the application that we want to build, so calendar in this case. All of the previous ones, so from 0 to 94, are dependencies. So this is from PIM, this is from PIM, this is from PIM, this is from frameworks, this is from PIM, this is from PIM. So many libraries from the GitLab group KDE PIM and from the GitLab group frameworks. Okay. Now that we have built, we need to go back to the page with getting started using kdesrc-build. So it says that you should build one application, which we did. It's the application calendar. And we built it like this. So kdesrc-build space the name of the application, so calendar, not kcalc. And then we can run it like this. So let's do that, copy. Control G, whatever I did, I don't. Okay, so what this thing does is sets up environment variables in such a way such that the application to be run will be preferred to be from this directory, from ~kd/usr/bin. So this is the first directory that it will search for when searching for the executable called calendar, not in /usr. You might have calendar installed from Ubuntu packages into /usr/bin, but that will not be preferred. The one that's going to be preferred is ~kd/usr/bin/calendar. And then similarly, all of the KDE libraries and QML directories and other files will be preferably taken from ~kd/usr, not from /usr. So kdesrc-run does two things. It creates an environment block such that the things from ~kd/usr are preferred over the things inside of /usr. And then it says run calendar. Okay. And setting that environment block is actually done by setting a number of environment variables. So kdesrc-run does two things. Sets some environment variables and then it says calendar start running. Okay. Calendar, one of the first things that it does, it says I need the PIM engine, which is called Akonadi server. Is that thing running? No, it's not. Then let me start it, and it starts it probably using dbus activation. So we can see it in here that the process has started, the Akonadi process. How do we look for the Akonadi process? We go ps aux. This shows us all of the processes that are running. The list is long because we're running a graphical user interface session. And this is a command line that we have run, ps space aux. Whenever I run ps to list the processes, I always use the command line parameter aux. So it says there's a colon column for the user of that process. This is the row of a process. So there's a process called /sbin/init, which is in fact systemd, which has a special process ID, the first one PID1, which is run by the user root, which was started 2 days ago. Okay, so what we care about right now is the user, the process ID, and the command line. Okay, and we need to search for one that has Akonadi, which is the Beam engine. Since the list is so long, we might not find what we're looking for. So the way to do it is you place the output of the entire command line inside of the file ~a.txt. So this is the greater than character on my keyboard, which means redirect everything that PSAUX would write to the terminal, to console, so the standard output stream and to standard output stream. Write that thing to the file ~a.txt. So this is the file /home/ my Linux username /a.txt. Okay, we don't see anything written to the terminal because everything that PSAUX would write normally to the terminal has actually been taken and written to the file ~a.txt instead. And now we can open the file ~a.txt with our preferred text editor, because in the text editor we can actually search for things. So we can go Ctrl F, Akonadi. Okay, and we can see that not one but a ton of processes have been started which are about Akonadi. So we have ~kd/usr/bin/akonadi control, ~kd/kd/usr/bin/akonadi server, ~kd/usr/bin/akonadi akonotes resource, birthday resource, contacts resource, iCal resource, indexing agent, maildir resource, maildir dispatcher agent, migration agent, new mail notifier agent. So Akonadi in this moment is this list of processes, which I'm going to guess are in fact a process tree, in the sense that Akonadi control has created a child process named, I don't know, Akonadi server or something. Let's look at the list of processes as a tree and see this tree of processes. That's PS3. Okay, and we're searching for Akonadi. Where is it? Okay, so these things. So systemd, which is PID1 that we just saw, started a ton of processes, and then this is probably the current session, the session that's running as my user, and Marius P, my Linux user, has the Plasma shell, which is the desktop environment running, but it also has other things, such as Pipewire, which is the sound server, Obex, which is part of the Bluetooth infrastructure, I'm going to guess. And then there's Akonadi control. And then Akonadi control has started Akonadi, Akonode, Akonadi birthday, Akonadi contact, iCal, index, mailing, dir, etc. And Akonadi server. And then Akonadi server has started 38 more Akonadi server, threads or processes or what are these. And then 4 more Akonadi control threads. Okay. The process calendar has started correctly. It works correctly. And we have started using kdesrc-run calendar. Now let's run it as the other way. We can close a.txt right now. So the other way is, let's write something more in here. So kdesrc-build calendar, this worked correctly. kdesrc-run calendar, this has worked correctly. And the next thing is for us to source this file. Okay, let's do that. So your source, and we need to source tilde/kd/build/kcal/prefix 5. So tilde/kd, I have a .5 in extra in here, so build, and then the name of the application, which is kcalendar. Calendar without a C. Calendar, this thing. And then at the end there's a prefix.sh. Okay, let's look at this file, how it looks like. Middle click paste. And it just sets environment variable. So says we like the existing environment variable path. But just prepend in front of it this part, so tilde/kd/usr/bin. Then it says we like this environment variable, but remove this part of it and prepend tilde/kd/usr/share. The same with this one. We like this one, remove this directory, and then, or what does this mean? Colon minus, and then prepend to it tilde/kd/usr/etc/xdg. To this environment variable, prepend tilde/kd/usr/lib plugins. To this environment variable, prepend tilde/kd/usr/lib qml. To this environment variable, prepend tilde/kd/usr/lib/qml/qtquick controls2. Okay. If you go source, then you can echo all of these environment variables and they will have the version, the value that is prepended, because source has edited the environment block of the current process and of all of its children. Okay, so this current process is called bash, and it has all of these environment variables set such that the files from tilde/kd/usr are preferred. Now all of the processes that we start from this bash will have this environment block, the new one, the one with prepended directories. So now we can just run the actual executable. So calendar. We have auto completion by pressing the tab key. And whether I do source prefix sh and then calendar, or I do kdesrc-run calendar, the output that we see in here should be the same, and everything should work out identically. Okay. So what I did, I added some sample events. So this is the calendar application. For the date Monday 6, I have added some events. Let's eventually, I don't know, delete one. How do we do that? I don't know. Let's look at the week view to have everything bigger. Right click on it and delete. Do you want to delete? Yes, I deleted the third one. Now I'm deleting the second one. Great. Okay. Next step is, since we know how to build the application from scratch, we know how to run the application correctly, let's, without any IDE, without any integrated development environment, edit something in here and make sure we can build the application calendar, that my changes are kept, and we can see the new changes in the application if you run it again. So what can we edit in here? Refresh all calendars. Let's see if there's such a thing, refresh all calendars. So for that, we need to go to the source code of the application. So that's ~kd/src calendar. And we want to get at the bit refresh all calendars. So Control S, refresh all. Calendars. Okay, so the PO files are used for translations. So this is actually the Ukrainian translation of the application. So it goes, the string in English is your names, and the string in Ukrainian is Yuri Chorno Ivan. Okay. The string in English is Ridu : and in Ukrainian is Povtoryty : Okay. So we should ignore all of the translation files. These are off limits, are taken care of by another team, which is the translation team, the internationalization team. We should not look at the .po files at all. What we are going to look at, though, is the QML files, which actually define the user interface. So let's see where this thing is, refresh all calendars. F4. So this is the calendar application. So there's a import calendar action and a refresh all calendars action, and this happens in the calendar application, which I do not know where that thing is. I can see edit undo, this thing, Control Z. I can see hamburger actions, where exactly where we were, so we're inside of the hamburger actions. I can see edit undo, I can see edit redo, I can see import calendar, and I can see refresh all calendar. So there's a chance that this is what I want. So let's go refresh all calendars, and then the today's date 0308, Control S. Okay, what are the other possibilities? Refresh all calendars. So there's a menu separator, which we do not have. So I guess this is not the one. Global menu bar, I don't know what that thing is. And then there's a menu bar. Okay, refresh all calendars. There's a separator before it also. So it's not this pop-up menu, which is the global menu, which is the hamburger menu. Okay. How do we build? So in this case, we have edit this file. Let's see if Ctrl-Alt-C works. Where are you? Okay, and we have replaced refresh all calendars with refresh all calendars 0308. Okay, and now if we just run kdesrc-build to build the application, my local changes will be lost. It will git clone the latest version of the changes, it will git stash my local changes, and it will try to build the source code from from KDE invent preferably. And I need to tell kdesrc-build, do not change my local commits that I did to the local Git repository. Okay, let's close the application. And I'm going to open a new tab and go with a really long command line. So kdesrc-build. Then I'm going to tell it the name of the KDE Git repository to build, so calendar. And then -no -src. You remember from kdesrc-build -help that there's a no src parameter, which we need to pass it in order to make sure that our changes are kept. Then -no include dependencies. You remember this one. Dependencies, right? Refresh build. This will do a full build. Let's try without, and then debug to see the most possible output inside of the terminal from kdesrc-build as possible. So kdesrc-build, calendar, no src, no include dependencies, debug. First of all, before doing anything, let's actually look at the source code and see how it looks like. Okay, so git GUI and then the ampersand says that the local Git repository has unstaged changes, just one file changed, calendar application.qml, just 4 or 5 characters added, so space 0308. So we like these changes. We could do a git commit, but it doesn't make any sense. We should just make sure that this file remains in here, unstaged change. Okay, so the history looks like this. The remote master branch and the local master branch point to the same git commit, the one with 4D96 with git silent sync pod docbooks with svn from 040416 0308. And then we have local uncommitted changes not checked into the git index, which is calendar application.qml, and just 5 characters added. Okay, so kdesrc-build calendar --no src --no include dependencies --debug, go. So what it did, it saw that the other dependencies of this project should not be built because we told it no include dependencies. Then it tried to run configure cmake. Then it runs the second step, which is gmake -j16, which using Unix makefiles, GNU makefiles. So there's three steps. cmake configure creates a GNU makefile. Let's look at it. So it's as all generated files inside of ~kd/build calendar, and it's called makefile with an uppercase M, F4. So this is the file that's generated by cmake configure using the backend Unix makefiles. And these are targets. No, these are targets. Okay, so install fast is a target, and then I don't know the build target, which one is. There's a test target for running tests, ctest, qt test. There's an all target, there's a clean target. If you want to do rebuild, you do clean and then build. When you do install, if the build target was not run completely correctly or something, it's going to see that the install target depends on the build target, so it's going to be building first, and then just after that it's going to run install. Okay, so install target depends on the pre-install target, which the pre-install target depends on everything including build. Okay, so this cmake, this GNU makefile was generated by cmake when we run, when kdesrc-build has run the first step, which is cmake configure. It has used the backend Unix makefiles, and it says in here that you should not edit. It's going to be regenerated by cmake configure whenever we run it again. Okay, so the first step is cmake configure just generates a makefile file in ~kd/build/calendar/makefile. The second step is going to run gmake -j16, 16 for the number of CPU cores that I have, and gmake will find the makefile available, and it will run the target, I know, default or all, or what's that, build, which in this case it's not a rebuild task, it's a target, it's a build target. So that's why it didn't build the files from 0% to 3%, so just built 3%, and then it jumped to 8% and then to 14%. So it has built only the files that have changed, and in this case just the QML file has changed. Okay, so the build is really fast because it's not a rebuild. It did not do clean and then build. It just did build, so it's an incremental build. Only the changed files have been recompiled. Okay, and then the last step is to go make install /fast. So the last step is to actually take files from ~kd/build/calendar directory and put them into ~kd/usr directory. But this entire step, the make install step, has been skipped. It says no changes from build, which is a lie, because a QML file has changed, and the generated executables contain a resource that has been changed. So the generated executables are different. So it says keeping install. Okay, but then it shows us the solution. You should always go refresh build if you want to actually write to tilde/kd/usr the calendar application, which is what we want. So we tried a build without refresh build. It did not work. Now we're back to actually using the command line parameter refresh build. So this thing. Copy. And before debug, does not really matter the order of command line parameters. I go like this. So kdesrc-build, the module to build calendar, --no src, --, no include dependencies, --, refresh build, --, debug. Okay, now it has run CMake configure from scratch. It has run rebuild, so full build. It did make clean and now make all. This takes a bit more time because it builds everything again. It uses all of my CPU cores. I have my CPU fan has 0 RPM, so does not spin at all. But when it is used, like it's in this case, all 16 CPU threads are used, then I can hear my CPU fan that it has started spinning. Okay. The second step, the make, has finished here. And now the third step, the last one, which is gmake install /fast, will take files from tilde/kd/build/calendar and put them in tilde/kd/usr, which we can see in here. So it says tilde/kd/usr/share/local. It's copied all of the translations, including the one that we looked at before, so the Ukrainian one. So this is the Ukrainian translation, the two MO files. And then it has created a tilde/kd/usr/share categories file, tilde/kd/usr/lib QML dir for Akonadi with an SO file with inside of the QML dir, it put collection combobox.qml, agent configuration form QML, so naked QML files, which is strange. Okay. And then inside of tilde/usr/share/plasma/plasmoids, it has added the org kd calendar contact. So this is a plasma plasmoid, so the entire desktop is called KD Plasma. Inside of KD Plasma, you can have this thing which are called the plasmoids. So you go right click, enter edit mode, and you go add widgets, and from here you can add the plasmoid that we just talked about, which is called calendar contact. So enter edit mode, add widgets, calendar contact. Not available because my Plasma desktop does not know at all about kdesrc-build, does not know at all about tilde/kd, which is the way I want it. I want maximum stability out of my desktop because I do my day job using this computer. So the only thing that knows about tilde/kd is the tab inside of console where I have run source or source prefix, or where I have run kdesrc-run. Okay, so the plasmoids, then meta info, then another QML dir for QML or KDE calendar contact, more naked QML files into /QML/org/KDE/calendar/mail. Another one, QML or KDE calendar components. And at the very last, the executable. So tilde/kd/usr/bin/calendar. This is the actual executable. Then there's a desktop file used for these things. So these are desktop files, or if I want to have an icon on the desktop, icons that start the application. So org.kd.calendar.desktop. This is metadata. This is the icon that's going to be used inside of the start menu and in the desktop file. Okay, so now that everything was installed correctly, we can run again calendar. So note that in my first tab in console, I have just run source, this thing. So I have already run source tilde KDE build calendar prefix.sh. So now I can just run calendar without any parameters, with an ampersand at the end. Okay, so this should be the new calendar from tilde/KDE/USR. So let's see if that's the case. Hamburger menu, and refresh all calendar says 0308. So we found the correct source code to edit. We've edited that, and then the magic incantation was kdesrc-build calendar, no src, no include dependencies, refresh, build, debug. Okay. So we know how to build calendar in such a way that our local changes are kept. The next thing to do is to actually use the ID, Integrated Development Environment. For that, we are going to go to the wiki page where we have the procedure on how to set up kdesrc-build and how to start programming for KDE. And there's a chapter in here about integrated development environments. So 1.3 integrated development environment. Click on this, and a chapter for Qt Creator. Let's go there. It's a wiki page. So says that there's a screen recording available. So you should definitely watch this screen recording. Okay. Okay, I have newer screen recordings for Qt Creator. So this is important, and this is important. So this is an integrated development environment. We want the latest and greatest and the newest version of this IDE. We want as much stability as possible inside of the debugger. We want the newest features. For that, follow this tutorial and see what it does there. So it says you should go to the website of qt.io, which is the official website of the Qt website. You should create a account in there, a user account. Using that, log into qt.io, then download the open source Qt installer, and whatever, follow the screen recording the way I do it. Okay. And then after you finish installing it, it will appear in the start menu. And let's follow the tutorial with ID configuration Qt creator. Okay, I tell you that you should download from the Qt website, so do get that. Do not install Qt creator from the Linux OS. Get the latest version from the Qt framework website. So it says the kdesrc-build should have DC make build type debug, which we do. We have built an application using kdesrc-build without errors, so not kcalc but calendar. And now we're starting Qt creator. We did that, and then we're following the procedure. So it says from the Qt creator main menu, file, close all projects and editors. File, close all projects and editors. Okay. Then file, open file or project, this thing. Then we need to select tilde/kd/src/calendar/cmakelist.txt. We have that thing in here. So the src directory, calendar. Let's copy this directory, Ctrl A, Ctrl C, Ctrl V, and cmakelist.txt. We go open. And then on the left sidebar, switch to projects mode 5. So this thing. Switch to projects mode, Ctrl 5. We should go to manage kits. Under manual, remove all kits except desktop default. This guy, remove. Apply. Okay. Now again, manage kits. Under manual, everything that's not italic. So remove this, keep desktop default. Apply, okay. So I finally managed to delete all of the extra kits. Now we go button import existing build, this button, and directory tilde/kd/build/calendar. Ctrl V, build. So I paste the previous directory and I replace src with build. I go choose. Okay. So it has run cmake configure automatically. In here, so it says running usr bin cmake -s tilde kdesrc calendar -b tilde kd build calendar, and will install in tilde/kd/usr. And we should run the prefix.sh file to set the environment variables for calendar. Okay. It has found the needed cmake dependencies. So optional have been found, required have been found, and build files have been written to tilde/kd/build/calendar. So in here it wrote at least the make file with an uppercase M. Okay. So the first step, cmake configure, has been run automatically by the IDE. If we want to run it again, we go build and then run cmake. Let's do that. Not needed, but I did it anyway. The next step is to look in the left sidebar, switch to projects mode, this thing. Where are you? Yes. And then I need to change the active project to be the actual executable that we're running. Okay. So I clicked on the projects, and in here it says build and run, not the desktop kit, so imported kit, yes, that's the only option. Then it says build settings, correct. Build, edit, build configuration, this thing says debug to, correct. And now we can run. So the button build project calendar, Control B, which is the same thing as build or project, so Control Shift, build project, Control B. Okay, so let's press the button this time, the hammer button. This will actually run the step make minus, without any minus J's. The output is now in compile output alt 4. So it built. It was build, not a rebuild, because I can see it jumped from 5% to 23%, and it was really fast. Okay. Click on the left sidebar. The button above run, Control R, this thing, should say kcalc, in my case calendar, which is the name of the Git repository. Kit, not the desktop kit, so the imported kit. And build, let's click on this thing. So it should be build debug to. And to run, it should run the actual executable, the actual GUI the GUI hub, which is this thing, calendar. Okay, so let's select calendar in here. CMake configure was run automatically. You can run it again from the Qt Creator menu, build CMake. You can build by pressing the hammer icon with the tooltip build project, Control B, or from the Qt Creator main menu, build project, Control B. Okay. And now we've selected what target to run and debug, which is the same thing as going in the left-hand side, projects, build and run, imported kit, and then run. And in this combo box, we can select the actual, all of these are executables, so ELF files and executable. All of these exist in tilde/kd/build/calendar/bin directory. And out of this, I'm selecting calendar, which is the actual GUI application. The rest are C test, Qt tests applications. So let's select calendar, which is already selected. Okay. On the left sidebar, it's the switch to this thing, switch to edit mode. Select projects from this combo box. The only useful options here are projects and file system. So let's go with projects. I'm going to expand. So I'm go calendar, which is the actual CMake list.txt top level file. Then there's src, which is actually a subdirectory, this thing, which has its own CMake list.txt file, which is this file. And in there, there's an executable defined. This thing, which is called calendar, which is represented as this item, which depends on all of these files. Some are header files, files with extension .h. Some other files are source files with extension .cpp. And then there's resource files. Okay, and the kconfig file. So from the source files, we're looking for the C++ source code file, CPP file. That's the actual entry point to the executable calendar, the UI, the GUI application. The only file that could contain that entry point could be main.cpp, so double click on it. And now this is the editor. Let's close the find bar. The editor has a number of combo boxes. One is the list of files opened in the editors. There's just cmake list.txt and main.cpp. You can also see them in the tool view open documents, that you have a cmake list.txt file open and the main.cpp file open. The text editor, unfortunately, in Qt Creator does not have a tab bar. So this is a tab bar, which does not exist in the Qt Creator IDE. So you need to either use the Open Documents tool window or use this combo box to get at the correct open document. To close the currently open document, you switch to it and then you press the close button. So Ctrl W, as in all web browsers, to close a tab, or click on this button. And now there's only one open document. We can see it in here in the combo box and in here in the Open Documents tool window. We're in main.cpp. The second combo box in the text editor is the symbol export symbol that's defined inside of the text editor. So this text editor defines just 3 symbols. There's a using namespace kcalendar core. There's a static free function named raise window, and then there's another function which is free, and it's int main int argc int char argv double pointer, which is the actual entry point for C++ applications. So let's go there. We can select from this combo box and it will jump at line 47, which is the first line in the where the symbol is defined. So if I select in this combo box raise window, it will go to line 41. If I select main, it will go to line 47. We can put breakpoints in here by clicking to the left of the line number, like we did in here. And now it says select main, which we did. Click on the line with the opening curly bracket. This thing, we can go debug, set or remove breakpoints. So click on line 50 and debug, set or remove breakpoint F9. Okay, left sidebar, start debugging of the startup project. We're not going to press this button yet because we want to do this thing if Qt Creator fails to run the executable correctly. So I'm not sure why sometimes Qt Creator manages to run the executable correctly, but it should not. So Qt Creator needs to be told about the environment variables that have been set when we have run. Where are you? So about this file. So the IDE, before actually starting calendar, should set all of these environment variables to prepend before the environment variable path directory, before this directory, before this environment variable, this, and that. So before all of these environment variables should append some things. Okay, and the setting is this. So I have converted this file into this yellow block of text, which can actually be understood by Qt Creator, because Qt Creator does not understand this syntax. This syntax is for GNU Bash, the born again shell, and we need to convert this syntax, the born again shell syntax, into syntax that can be understood by Qt Creator, which I did. Okay, so let's take this part, copy, and unfortunately, because I do not use tilde/kd, I need to actually edit this block before feeding it into Qt Creator. So my KDE, Ctrl+C, Ctrl+R, Ctrl+V is actually KDE.5. Okay, replace all. Ctrl+A, Ctrl+C. So we should go to Qt Creator, and this is a QML application, so I do not expect it to work correctly if I do not set the those environment variables. So in the left hand bar, this guy, switch to projects mode, Ctrl+5, this thing, build and run, this thing, imported kit, this thing, run settings, environment, this thing, use build environment, press the details button, press the reset if available, nothing to reset, cannot press the reset button, which is okay. Press the batch edit button, paste in there. Okay, so says to the environment variable path, you will prepend this directory to the xdg data dirs environment variable path, environment variable, you should add this, prepend this directory, etc. So for each of these environment variables will have some directory prepended. Okay. And now we can actually start debugging. So we have put a breakpoint inside of main. And now from the left sidebar, we can go start debugging of startup project, which is this button. Start debugging of startup project. Click on it. Okay, it shows me this error. I have just 2 breakpoints, which is correct. And it has stopped correctly in main.cpp. I can collapse hide left sidebar Alt-0 to hide the projects and open documents tool windows to make more room for the text editor. This is Git history. This is showing the current value of the local variable and the argument argc. So argc has value 1, argv is an array and has 1 item. And then it says from the Qt Creator main menu, there's the debug menu where you can select either step over F10, which will go from line 50 to line 52, or step into, which goes from line 50 to another file, or step out to go from this file to the parent file, the file that has called this file. So from called function to the caller function. Shift F11 steps out. F11 steps into, so if you call a function, it will step into that function. We'll see it immediately. Okay, so we'll need more space for the IDE. And let's start inspecting things. So argc is this thing. It has the value 1, type int. argv is char pointer, which means char pointer is an array of 1 byte chars, which probably means UTF-8, 0 terminated, so null terminated. And then there's another pointer, so it's an array of these things, and that array also is, I know, might be 0 terminated. Anyhow, we do have the count of items of the argv array. Okay, so let's expand the argv array. So it says has just 1 item. First item in arrays in C++ is the item with index 0. So at index 0, there's this thing which is a const char pointer, UTF-8 0 terminated, null terminated string, which contains the following characters: /HOME/N. So each of these is a 1 byte character ASCII char. So let's look at the ASCII table. So there's a site, it's called ascitable.com, where we can see the ASCII table. So this slash is in fact a integer of size 1 byte of type char, which has the value 47. This h is in fact an integer 1 byte type char with the value 104 in decimal, so 104. Okay, and these characters being existing in the English alphabet and on my keyboard stop at 127 decimal, so they only use the 7 bits out of the 8 bytes inside, so only use the first 7 bits out of 8 bits in a byte. So only half of the storage inside of a char 8 bit is actually used. The most important bit will be used for the UTF-8 encoding. Okay, all ASCII strings are also UTF-8 valid strings. And this string is both an ASCII string and a UTF-8 string. Okay. Then what do we have? The rest of variables are going to be defined later in the body of the main function and are not initialized yet. So let's go F11. We cannot step inside of set attribute because this is a function from the Qt framework, and I do not have access to the CPP files of the Qt framework because I have installed Qt using Ubuntu 22.10 deb packages. So QGUI application the same. I cannot step into if I do not have CPP file where this function is defined. If this function happens to be, if this symbol happens to be a C++ metaprogramming, then I have access to that because the body of metaprogramming identifiers is defined in .h files, so in header files, not in CPP files. So I do not have the CPP files from the Qt framework, but I do have the .h, the include files, the header files from the Qt framework. So those live inside /usr/include because I have installed those using deb packages from my Linux OS. Okay, so I cannot step into this thing. F11, cannot step into this. F11, I can step into everything that's KDE because I have CPP files for all of the KDE source code. So if a symbol comes from a KDE Git repository, I have git clone that using kdesrc-build from invent.kdE.org, and it lives in more places. It lives in, so this thing, klocalized string, lives in tilde/kd/src/kinternationalization/src. and then its .h file lives in two places. In tilde/kd/src/k internationalization and in tilde/kd/usr/include. Let's find this exact file there. So it was make installed because it's a header and it's needed in order to build other software into tilde/kd/usr/include, and the name of the file is klocalized string, so Control S, klocalized string.h. Okay, let's go there. So this file klocalized string.h exists in two places, both in tilde/kd/usr/include/kf5/k internationalization as klocalized string.h, and this is used when building other software that depends on the KDE Framework 5 K internationalization. This .h file is being used. And then there's another place, klocalized string.h, which is the source code. This was git cloned by kdesrc-build in tilde/kd/src/k internationalization. And this file, the one in /src, has been copied here inside of tilde/kd/usr. Okay, and the CPP files exist in just one place, in tilde/kd/src. Okay, so this is called the S, which is a static private, which is a C++ technique that is used by KDE and Qt source code. Q global static. Okay, so this S thing can be inspected. So it's just a data struct defined here. We can go control click on it. So it's a data struct, just contains storage, so just member variables, not methods, and all of the storage is public. So there's a QString list, is a list of strings named languages, and QHash is a dictionary from qbyte array, which is actually a string, to kcatalog ptr hash, which is another dictionary. So inside the dictionary catalogs, there's another dictionary, which is this thing, which goes from string to pointer to kcatalog. Qbyte array is a string, qbyte array is a string, const qstring is a string, qstring list is a list of string, const qstring is a string. So the fans, start interp, end interp, script plchar, script vachar, another string. This is a dictionary from string to list of string. This is a list of string. This is a pointer to whatever this type is. Contains an eval method. Okay. This is a dictionary from string to pointers. This is a list of string, list of int. This is a mutex for synchronization between threads of the same process. This is the constructor, and this is the destructor, and it contains a method. So let's look at the constructor. The constructor initializes all of the data members using initialization syntax, so colon and then slash. And in the body of the constructor, it calls this method that it has defined, initialize local languages. And after this thing does its thing, it does this assignment, because I guess this function actually writes this member variable. The destructor does qDeleteAll, which takes a container and deletes every member of the container, starting from begin and ending with end. So deletes language catalogs, which language catalogs is what? Is this catalogs thing. So this q hash of q hash. I use the go back arrow to go back. So, or alt left, similar to what's in web browsers. Alt left, alt right. To go back in history in a web browser, you would use alt left arrow key and alt right arrow key to go in the future. Okay, and then the initialize local languages method. So this is a method that's not static, is member of the object, not of the class. It locks the mutex such that it doesn't get called twice, and then it calls this free function. Okay, so this is called the call stack. It starts from the main function. The main function on line 54 has called setApplicationDomain, which is a method, a static method from klocalized string, this thing. If we want to exit the method setApplicationDomain and get back to the main function, we can use the button debug step out shift F11. And we're back at line 55 in main, and the call stack contains just one element right now. This is the list of threads. You rarely use it. And this is the call stack. This is the list of breakpoints. You need to clean up the list of breakpoints from time to time, because the breakpoints disappear from here only if you delete them. List of threads, breakpoints. Okay, so these are the local variables, the locals tool view, and then there's the expression tool view. This again contains things that I have evaluated many weeks ago, so I should select everything and press the delete button. In here we can add expressions. I know, we can have argv of 0, for instance. Let's do that. How do we do that? Right click. Add expression evaluator. What's that? Not that. Control C, let's add it manually. Add new expression, where are you? Control V of 0. Okay. So argv is already available by hovering on it. argv is already available in the locals tool view. And now argv of 0 is available in the expressions tool view. Again, as shown previously, this slash is in fact 47. This H is in fact 104, this thing. This O is in fact 111, which is Where are you? This thing. One decimal. This thing. Lowercase o. Decimal means base 10. 111. So lowercase o is 111. Okay. And everything ends with a 0, which is not shown here. So on position 48, there's a integer of size 8-bit 1 byte type char that has the integer value 0, which is also known as this thing, null \0, the decimal 0. Okay. So you can step into, step out. Step over is this button, which goes from line 55 to line 56. Now it will go to line 59. Debug, step over. Now it will go to line, to line 64. Environment variable is empty Qt quick controls style. So there is no such environment variable. It will set the style to org KDE desktop. Okay, so the application calendar is written in QML and is a convergent application. It can run on Plasma Mobile, which is the application written by the KDE community that runs on mobile phones. So on mobile phones you can have a graphical user interface that's called Plasma Mobile, and in there you can run KDE applications such as Calendar, and Calendar will do its best to fit the form factor of a mobile phone, and also to respect the small resolution that exists on mobile phones. Okay, and there on the mobile phone it will probably not use org.kd.desktop, which is the Qt quick controls style for desktop applications, but it will use the Qt quick control style for smartphones. So Calendar is a convergent application, works just as fine on a normal desktop laptop or on a smartphone. Okay, so we go F10. It also evaluates the values inside of function arguments. So that's why it jumps all over the place. This is just evaluating the arguments of the constructor called kAboutData. Okay, now it's evaluating the parameters of the aboutData.addAuthor method. Okay, that's it. I do not know how to edit the QML files. Where are the QML files? We go file system and src and quick and QML, and there's 2 QML files here. Then there's models, which are written in C++. Mail contains QML, conversation, viewer, folder view, mail application, mail sidebar, mail viewer. Okay. and there's contents, UI, there's bars, controls, delegates, dialogues. Unfortunately, I cannot help with QML at all. That's it. I do not know QML enough to help. Okay, but you know how to edit QML, and if that thing is valid, you know how to build it using kdesrc-build with many parameters, minus no src, minus no include dependencies, minus refresh build, minus debug. And if that builds correctly, you know how to run it using source, and then you only need to run source once. So for instance, in the first tab in console, I have run source once, and now I can run calendar with an ampersand as many times I want. And I remember that the first tab in console is where the environment variables have been modified because I called source prefix. So I can start calendar and close it as many times as I want, but only in the first tab in console. Okay. So let's close some files that are opening the text editor either using Ctrl W, or we can close them directly in the Open Documents tool view. So like this, and then the cute things. And we're back to main.cpp. Okay, this is functional. I do not know C++ functional part. Another functional. In here, you make available C++ symbols to the QML source code, the QML register type, QML register singleton, type QML register singleton instance. Okay, this is triggering a Qt style event. You will need to learn about the Qt programming language, about connect, about mock, auto mock, slot, signal. Okay, so before I stop having anything to say extra, I'll just try to exercise, if I can, the inspector. So debug, stop debugger. I can stop the debugger in here. I can run the application either from the first tab in console, like this, or using this button, the run, not the start debugging of the starter project. So I can run. It would do the same thing. And now if we want to inspect in depth the application as it's running, the solution that we have is called Gamma Ray. You search on my YouTube for channel for Gamma Ray. So this thing, KDub Gamma Ray. Okay, let's see if this thing works. So because I have installed Qt from my Linux distribution, I needed to also install Gamma Ray from my Linux distribution, because Qt and Gamma Ray are really intimate know of each other, so they must be at the same version. Okay, so this is the Gamma Ray launcher. I want to connect this application Gamma Ray to this application calendar. So it offers me in the list of processes that it can connect to the application calendar. I don't want to connect to Akonadi. Okay, the correct calendar, process ID 499470. Okay, it selects the correct Qt version, Qt 5, auto process, local debugging only, so everything is selected in here is okay. So I just clicked on calendar and then click on attach. Okay, and now I have this user interface. What can I do in here? If the application Gamma Ray does not crash, I can do anything. I can read everything that happens in the calendar application, and I can write a ton of the things that happen inside of the calendar application. The first thing I can do is go widgets. So it says that there's a QDesktop widget, a QDesktop screen widget, and then there's QMenus. How do I make this smaller? Okay, so there's the menu import calendar, quit calendar. I'm not sure what these are for. Then there's this menu, undo, redo, cut, copy, paste, delete. Then this menu, refresh all calendars, month view, week view, 3-day view, day view, schedule view. Then there's sort by due date, backwards, forwards to day, new venue task, enter full screen, manage tasks, about calendar. Okay, so menus. With this is all of the Qt widgets that exist inside of calendar. So the Qt framework has two parts. There's Qt widgets, so GUI controls in the style widgets, and then there's the GUI controls in the style Qt quick QML. So for that we go to quick scenes. Okay, so widgets, we have just some menus, whereas the rest of the application is written in QML and Qt quick. So that's why we need to go to the tab quick scenes inside of Gamma Ray. Okay, so it says that there's a Q quick root item, which is the thing that we're looking at right now. I can pick an element such as this hamburger menu. Okay, so this hamburger menu has the properties that we see in here. After it finishes doing its thing. So again, Gamma Ray can crash sometimes, not a problem. You close it and you reopen it again. And maybe this time you're luckier. Okay, so these are all of the Qt quick controls shown in a tree. There's a Qt quick root item at the top, and then everything is a child or grandchild, etc. of that top level item. And the hamburger menu is this thing, the private action tool button QML type that has a style item, a kirigami icon, and the kirigami icon is which? Meta object icon. Okay, does not matter. Somehow you can configure this kirigami icon to use the hamburger menu. I'm not exactly sure how to do that. Kirigami icon source application menu. So that's the way you do it. You create a cute quick QML binding from Kirigami icon from the property.source to the string application menu, and this is where this thing is defined. So on line 21 of the file, of the wrong file, so it seems that Gamma Ray does not know about the prefix. So maybe let's start Gamma Ray using that prefix. Okay. So I'm in tab 1 of the console where I have set the environment variable correctly. So on top of some environment variables, begin with tilde/kd/usr. Let's start Gamma Ray from here. Maybe this way it knows about the location of the QML files. I open calendar. I click on the pick element, click on the hamburger menu, wait for it to do its thing. Okay, it did this thing. So there's a style item and the Kirigami icon. I click on it. I go to bindings and it still goes to the wrong place. So it goes to Kirigami from /usr, which is from my Linux distribution, instead of going to the Kirigami from kdesrc-build. Maybe I did not build Kirigami. Who knows? Let's check this out. Okay. So usr lib qt5qml. usr lib, the long thing. QML or KD Kirigami. To this thing. Private action tool button. Okay, so instead of opening the correct file, which is private action tool button, it opens the wrong file, which is this one from /usr. Line 21.